Hey everybody, this is a video about Zadc by Collider Modular. Zadc is a very simple analog to digital converter. Now I know what you might be thinking, aren't we already dealing with the digital domain? Yes we are, but we're converting from virtual analog to virtual digital here. It's very easy to use and it can serve as a source of random gates or latching for all different kinds of projects that you have. Let me show you how it works. All right, so starting out here, getting this wired up, you can see I've got a sync generator and a sync divider off to the side, and I'm going to patch the clock signal to the clock. The clock here really represents the sampling rate of converting from analog to digital. You can make this as fast or as slow as you want, and really it depends on what you're doing. You'll see that as we get going here. There's a second thing that we need connected to Zadc in order to make this work, and that is some kind of incoming control voltage value. So I have an LFO going over here, and I'm just going to patch that in, put the sine wave in. Now you notice that as soon as we do that, a handful of things start happening. First of all, this number up here at the top is changing. And second of all, these LEDs down here are turning on and off. Now, the idea of an analog to digital converter is we're going to take the incoming signal, and the range of this signal is negative 5 volts to positive 5 volts. And instead, we're going to convert that into an 8-bit representation. Now you can see over here what the different numbers are. So in other words, we're going to convert negative 5 volts to positive 5 volts into a number between 0 and 255. And you can see what's happening over here as these numbers jump around that is actually the number that it is being converted to. This number is then taken and it is converted into its binary representation. And in binary, 255 is represented by 8 ones or zeros. And so you can see where this is going. There are 8 output channels of Zadc, and each time there's a 0, the gate signal on the output jack will be low, and each time that there's a 1 in binary, it will be high. Let's take a look at what this looks like on the oscilloscope here. I'm going to connect the first 4 output jacks so we can see what's happening. Maybe scale this down a little bit here. And so you can see what's going on is as we feed it this signal, it's turning on and off. Now the mode that we have it in is maybe not the most obvious mode, so let me change. You can see there's a switch here and we can toggle between latch mode and trigger mode. Trigger mode is a little bit easier to understand, and that is every time that we get a clock signal on the input, we will convert the incoming control voltage into its digital representation, and there will be a trigger each time that bit is true. And so if you watch over here, you can see whenever the LEDs flash green, it will correspondingly flash a trigger signal over here. Now this mode can be great if you want to, say, have random triggers to fire off drum modules or other types of effects. This can be a good mode here. Now when we're in trigger mode, this knob here will allow us to control the length of the trigger. So we could drag it out to make it a little bit longer if there's something we're doing with it. This is particularly handy when you're triggering drum modules and it's running in gate mode and you want to give a little bit more width to that gate. Now the other mode, which is the one that I like the most because it allows some creative usage, is latch mode. Now latch mode, you can think of it as a gate where the signal will not drop low if it is going to remain high. When this clock signal comes in and it evaluates all of these numbers, the output jack will either be set high, 5 volts, or low, 0 volts. But what will happen is each time this clock signal happens, if the evaluation continues to keep that bit high, it will not introduce a little spike and drop it low. It will, in fact, stay high. And so you can see as I slow down the clock rate, we can start getting these gate signals that last and stay high for really long durations of time. And this is particularly useful for all kinds of creative effects. In fact, if you ran these signals through an attenuator, you could even use this as a modulation source to add a lot of rhythmic modulation to your patches. There's a couple of other things, and then I'll wrap up this video because this is a very easy to use module, and that is this switch here. So for each output channel or each output bit, there is a 3-way toggle switch that will change the behavior of that channel. So when it is off to the left, in other words, when we have this solid circle, it will be running in normal mode, which is what you've been seeing. In the middle position, it will be muted. There will be no output, so you can see up here on the top, we're not getting any output. And then on the far right, it will be inverted. We will get to the opposite of what we were getting. So where this comes into play in particular is as you're doing performance and you have different things connected to these, you could, for example, if you're using this as a modulation source, start them all out as muted and then turn them on as a creative effect. Or in the middle of your patch, you could change something to be inverted and start getting the opposite effect out the other end. There's a lot of fun uses here, but let me show you one in particular. And because I do have other modules available in the store, I'm going to toot my own horn here and show you how you can use this with some of my pitch modules. So here, for example, we have Septitone. Septitone is a quantizer that allows different scale degrees to be turned on and off. And one of the things that you may notice here, and this is no accident, is that there are 8 outputs of Zadc and there are 8 gate inputs of Septitone. So for example here, if I got this wired up, we could use something like an ADC module to, maybe slow that down a little bit. We could use something like an ADC module to change the state of our quantization at a very regular cadence. Another thing that we could use this with is the Zum pitch summator. So once again, you notice that there are 8 inputs here, and we could use all of these gate outputs to feed Zum. So there we go. That gives you an idea of a couple of the things that you can do with Zadc, and in particular, the ways that I had intended it to be used with the pitch module offerings that I have. I hope you enjoy this and have fun.